a leader in web business. Ms. Ainoa has much to teach us this afternoon. So now please join me in welcoming Ms. Cheryl Ainoa, Senior Vice President of Global Service Engineering at Yahoo. Thank you.
Hi, thank you very much for having me. Actually, it's quite an honor, and it's always very exciting to get to talk to people that are out studying and going to be the people who come up with the latest innovations coming out in the future. Some of the most exciting and fun and challenging technology challenges are not necessarily with the new product itself or coming up with that new idea, but it's with being able to take that idea and deliver it at scale to a global audience. And so that's what I'm going to talk a little bit about today, and we'll go through kind of why scale matters, kind of what it looks like, just to set some context, some specific challenges that scale brings, and then I'm going to take you through 2 case studies of actual projects that I've had the fun to work on in the last couple of years at Yahoo. And then at the end, we'll leave it open for Q&A. So first of all, why scale matters? Well, one of the first things you learn when you get out in the working world is that it's all about the money. At the end of the day, businesses survive, they have stockholders, they have owners, and they all want to have a return on their investment. And to run a successful internet business, you really need 2 things. Well, you actually need a third thing, but the 2 things you need is you need lots of eyeballs, you need people coming to your site, and you need them doing lots of things. Now, those things may be different depending on the type of business you're in. So if you're an ad-driven business, you want lots of people that come and see lots of page views and click through ads. If you are somebody like Amazon, you want people to buy lots of products. If you're Netflix, you want people to subscribe. But at the end of the day, you want every person to do a maximum number of transactions. Scale in these contexts, now actually, let me go back. The third thing you actually want is the ability to monetize the people that come to the site, but that's not usually a technology challenge, so I'm not going to focus on that in this talk. We're going to assume that if you are a business and you've got lots of people coming to your site and they're doing lots of things, that you know how to make money from that, okay? Well, but we'll leave that to the MBA portion. Scale comes from really 3 things. It's not purely the number of people that are coming to your site and the transactions they're doing. It's also the number of markets that you're serving. Okay, so serving just the US market is one market. When all of a sudden you're serving all English-speaking markets, that's another scale. When you start going into supporting Asia-Pacific markets, it's another scale. And so in Yahoo today, for example, we're in over, I think actually latest count, we're up in over 52 different countries. So when we develop a product, we're not developing it for a single market. We're developing it for the ability to go out into, X number of countries and markets across the world. Number of devices. Well, this is something that's just really taken off in the last couple of years, and boy, does it make our life fun and challenging and interesting. So it used to be all we had to worry about was the browser, and maybe we'd have to worry about differences in browsers and OSs. But now you've got, the world is moving more mobile. You've got everything from the iPod and the iPad and iPhone and Android phones and all the different mobile devices and the smartphones and the hero devices. So actually, Yahoo today in our products we support over 350 some devices. So it's very, very complex. Now you can choose not to support that many devices, but what that means is you'll have a smaller base of audience coming and doing less things. So, and in this day and age, the internet really is ubiquitous throughout people's lives. So people don't generally just do something on the browser. People want the ability to have their online life follow them throughout their day, no matter what they're doing. So the ability to basically bridge between their mobile device and the browser or whatever device they're interacting with at some point in time. Could be their refrigerator. Have you seen some of those fridges that actually have little mini computers on them and TVs and all sorts of things? So you can see people wanting to, I don't know, have a grocery list in, I guess that's why you'd have a computer on their fridge. I've never really figured out why they wanted to have a computer on the fridge, but they have them. And so people want the ability to not have to take and copy things between devices and have a big disconnect between those devices. They really want the ability to seamlessly move across devices in the context of what they're doing at that point in time. So if you wall yourself off from a set of devices and say, hey, we're not going to support any mobile devices, or we're not going to support any Androids or anything like that, which makes it a lot easier technically, because you have less things you have to support and less different variations that you have to code for. But you're going to cut off your market space, and you're actually going to probably significantly decrease your user experience, because you're not going to have the ability to take that experience across those device boundaries. Okay, so what scale looks like. You guys have probably heard of PB&J, right? Peanut butter and jelly. When I talk about scale, I talk about PB&H. So it's all about petabytes, billions, and hundreds of millions. Okay, so for us, Yahoo scale means, we've got more than 600 million users per month. 1 of every 2 users of the internet in the world today comes to Yahoo. And in any given day, 1 of every 12 internet users comes. So that's huge in terms of scale that we have to deal with, and that we have to make sure they have a good experience. Because if they don't have a good experience, they won't be coming back tomorrow. Hundreds of thousands of servers, hundreds of petabytes of storage. We store, I think we have 40-some% of the world's email. So you're talking terabytes and terabytes and petabytes of data that we store. Flickr, those kinds of things. 20,000 different cluster configurations. What this means is different individual software components that have to be individually monitored and managed for various reasons. We deal with more than 130 billion spam emails a day that we filter out and protect from getting to our users. And some actually, if you're a Yahoo Mail user, you can never get them all. But we're getting rid of 130 billion, and still some are getting through. 45+ countries. This is actually old data. The latest data I got was actually 52, I think. We've expanded into a number of the Arab countries through our MacTube acquisition. And as I said, 300+ devices. So what are some of the unique challenges that you get into at scale? Well, my dad was an aeronautical engineer, and he does not understand computers very well. Don't tell him. He's probably going to watch this on video, so I probably should not have said that. Sorry, Dad. Anyways, so I was trying to explain to him what does scale mean in the world of computers and what it is that I do in my job. And so I was looking for an analogy, and I finally came up with, hey, Dad, kids building a model rocket in the backyard. The amount of preparation and technology challenge that goes into building a model rocket that's going to shoot a couple hundred feet in the air is on a completely different scale than what goes into a NASA launch. Would you agree? And he agreed with that. Being an aeronautical engineer, he probably had to. So they both, if you look at it, it's ironic. They look pretty similar in design, in reality. And now, okay, this one's actually, the scale isn't right, clearly. But they have a lot of the same components. But by the way, they do a lot of things similar in just the launch itself. The whole launch sequence is very similar in terms of how the fuel is ignited and the whole ignition sequence, et cetera. But when you're talking about a NASA launch, you're talking about having to deal with the extremes of temperature. So here, you can use cardboard, aluminum, whatever, to build your rocket. When you're talking about going, millions, well, tens of thousands of miles into space, you're not going to be building that out of aluminum and cardboard. Actually, there's a whole science, and there's thousands of people out there in material science who deal with building of specialized materials that can handle the extremes of the temperature that you get, so that the rockets don't self-destruct or burn up or freeze over wherever they're, when they're launching or when they're returning. Additionally, in model rockets, you don't have people going up in them. So the difference there in your risk tolerance is night and day. You're going to take a lot more caution with dealing with things like gravity and all sorts of things in here versus here. So, the technology that has come out of the NASA space program over the years is amazing and is used in everyday life. I mean, I think Velcro is probably the most obvious example. Tang is another. I don't know if you guys drink Tang. But there's many more that I don't have off the top of my head. But, Velcro, I mean, I don't know. I think I have Velcro I use every day on something or another. And those challenges came out of dealing with the types of changes, the types of technology challenges that you're dealing with at scale. How do you keep things in position at zero gravity? Velcro was the solution to that. So that was kind of how I explained it to my dad in terms of the difference between, putting up a little website that's running on a server in my closet that maybe if I'm really lucky, 10,000 people a day, and having a site that's having hundreds of millions of people coming, generating hundreds of millions of page views in a given day. Just completely different challenges that you're dealing with in what you need to do to be able to support that. So I kind of refer to it as a technology challenge curve. Now, any of you who've taken any MBA courses will know I actually stole this curve from the technology lifecycle adoption, Geoffrey Moore thing. And actually, I think that the technology challenge curve has multiple chasms, but you can consider the x-axis here, any of these or any combination of these. And as you move through much greater usage, so down here, say if you launch a site and you get up to maybe 1 million users, pretty simple. You can stick it on a single server, probably don't really care if it goes down. Very simple to run. Not really worried about taxing out the CPU, your storage, or anything like that. When you start to hit 1 million users in a day, or certain peaks in a given second or minute, you get to a point, about 1 million is what we usually look at Yahoo. There's points about 1 million, 10 million, 30 million, 50 million, about 100 million. Those are kind of the points, depending on the application you're working on, where you start to run into those new kinds of challenges that now have to be dealt with, or you're not going to get across that chasm. Your site's just going to fall over, or it's going to have a very bad user experience. So really, those challenges, or what determines those curves, as I said, the x-axis, are driven by 5 things. One is the usage. How many people are coming, and how much are they doing while they're there? How long are they staying? The second, as we talked about, was number of markets, number of devices. Risk tolerance. As your site, when you have 1 out of every 2 users coming to your site in a month, if Yahoo front page is down for an hour in the middle of the day, we aim to lose millions of dollars. If Cheryl's favorite pet website that I put up last night is down for an hour in the middle of the day, not so much. Okay? So as you get more successful, the risk of an outage becomes much, much higher, and your risk tolerance generally is much, much lower. And because of that, it creates new kinds of challenges, and we'll talk through those in a little bit. And the last is cost. This one's a little different than the others, but as you start moving up the scale, the cost of a given thing starts to become much more significant. So, for example, at Yahoo, I've got to make sure I don't give away anything I'm not supposed to say. But let me just say, the cost of purchasing a server is roughly equivalent to the operating expense of operating that server over, on an annual basis. So it's not so much just, hey, it's $1,000 for a server, who cares? It's the fact that that server draws down power, it has to have a place to sit, it takes cooling for the building, and it takes a building to stick it in. And when you're talking 250,000 servers, every 80,000 additional servers, we have to build a new plant. And so that's another $100 million. And when you're talking about rolling out new applications that hit hundreds of millions of users, those servers add up very quickly. So the cost of any individual item, or the unit cost of power, for example, not something you worry about when you're running 1 or 2 servers. When you're running 250, 300,000 servers, the amount of power per server becomes a big issue, because it increases your expense, which lowers your margin. So we'll end with that there. So we'll go through this a little bit. The usage scale challenges. So this is when you have, oops, 1 second. Okay. When you have massive amounts of people coming to you, what are the challenges that come from that? That's a good problem to have, by the way. We like it when lots of people come and stay and do lots of things. But you really start to push, just from the sheer volume of activity, you start to push the technology limits on the basics, the CPU, the storage, and the network. Okay, when you're running, again, a simple app on a single server, single CPU server, you don't worry about it. When it starts to reach the point where you get to a certain utilization rate, well, now maybe I need to go to a dual-core or quad-core system. Well, in order to do that, I have to make sure I've got threading enabled in my application. So that's a new level of complexity and challenge that didn't exist before. When I hit a certain level that I no longer can meet the physical limits of the maximum computing power in a given box, I now have to have the ability to run my application across multiple boxes. Well, now I'm talking about load balancing. I'm talking about hopefully load balancing within a single location, but potentially across multiple locations. When I get to a big enough scale, I'm looking at, gee, the software load balancing doesn't work anymore. Now I have to make trade-offs between software and hardware load balancing. And again, the technology challenges you're dealing with are new as you approach each of those new layers. Same thing on the storage and the network side. I could give you equivalent examples there. And the other thing is, when you get to certain scales, again, Yahoo is at a scale that, there's maybe 3 or 4 companies in the world who have the type of activity that we have. That's good news. We like that. The bad news is that commodity solutions out there are not built to meet the top 3 or 4 companies in the world. They're built to meet the massive market. And so a lot of times, while there might be solutions out there in the marketplace, they may just not work at our scale. And there are places where we actually have to go create our own solutions for things that you would think we could just pick up off the shelf, virtually. But they just don't meet our needs. They're going to fall over when they hit certain limits. So it means you have to go invest in developing technology and things you may not think you should have to. And you have to get very good at it. Load testing. Boy, how do you load test something that serves 300 million users a day? You have to create, if you want to stress test it, you have to take it up 10 times that. How do you even create that much? So it gets pretty interesting, the algorithms that you need to build to actually create enough traffic to actually stress a system that's already built to handle hundreds of millions of users. And the last thing is, and again, it's one of those good news, bad news. One of the prices of success is the bigger you are, the bigger a target you become for abuse. So we are one of the biggest targets for spammers and all sorts of abuse. Any type you want to spell out, we get it. How many of you out there are actually computer science majors versus a different kind of engineering? If you're a computer science, raise your hand. Okay. Okay. What other kinds are out there? I'm curious. Any material science engineering out there? Okay. Any electrical engineering? Way to go. What am I missing? Chemical, mechanical? Okay. The 2 case studies I have are both software examples. I did consider bringing in a third one, which is actually around the building of data centers. We probably have the world's expert in green and cost-efficient data center design. As a software and electrical engineer, I never really appreciated the technology challenges that went into building highly efficient and leading-edge data centers. But I've worked with this guy over the last year or 2 as we've approached a lot of these different types of cost limits. And boy, it's amazing, the interesting technology you get into there. So I apologize for not using one of those examples. I wasn't sure how broadly that would apply to the group here. So hopefully I'll try not to get too into the depth of the computer science stuff. All right, so that kind of ends up the use challenges. Global challenges. This is, again, another good problem to have, and something that if a startup becomes successful, they will deal with this problem sooner or later. Because you get to a point, if you're successful in the country you're in, you get to a point where your penetration is such that the only way to grow is to go out into the broader markets. So it's a good problem to have, but it does bring a whole new suite of fun challenges and technology challenges. One is just multiple languages. You know, I thought I was really good when we did kanji on some of the products I did, and then we hit Arabic, which you go right to left instead of left to right. And that presents all sorts of interesting new things in how you code your logic. And you find out all the places you didn't really follow good practices in abstracting your display logic from your application logic. You find that out real quick when you start talking Arabic. Well, not talking Arabic, but implementing your product in Arabic. There's also different usage patterns. So, you know, the areas that are growing the most right now, and certainly the areas that have, you know, for Yahoo, the next billion users are not going to come from the US. They're going to come from emerging markets. It's going to come from Asia Pacific. It's going to come from India. It's going to come from the Arabian area. It's going to come from Indonesia, Brazil, those areas. And how people are interacting with the internet is very, very different in each of those places. In Indonesia, very few people actually have PCs. Most people go to internet cafes, and they go literally once, twice a day. But that's how they interact with the internet. It's very much a part of their lives, but it's in a different way than we do things. In Asia, almost everybody has a cell phone. I mean, we all have cell phones here too, but they take it to a new level. What do you think is the average age that a child gets a cell phone in Asia? What? 7? 5. That's right. That's the correct answer. 5 years old. I have a 6-year-old. She thinks I'm abusing her because she doesn't have a cell phone. 5 years old. Isn't that amazing? So it's a very different usage pattern than here. I think the average age in the US is quite a bit higher, I'd hope. Yeah. So what that means is when you develop your applications, you have to develop them in such a way that they're flexible locally. And this really means you have to really get a very clean abstraction layer between the display logic and the application logic, so that you can, with a very lightweight, very simple switch between the user experience so that you can be successful in any given market and in how they're doing things, but you're not having to carry 52+ code bases for every product you have because everyone has to be done separately. That wouldn't be cost effective. The cost of compute infrastructure. This is a big challenge globally. The cost to serve, and I mean this fully loaded, so this is the cost of the facility, the power, the bandwidth, the rack, the equipment. 3 times to serve the same traffic out of Asia Pacific or EMEA. I'm sorry, EMEA is emerging markets, Europe and emerging markets, basically. I'm not sure what the exact letters mean, but it costs us 3 times to serve the same amount of traffic that's doing the same exact thing in EMEA or Asia Pacific as it does to serve it out of the US. Now the easy business answer is serve it all out of the US. Unfortunately, the laws of physics are against you there, because if you want to wait 3 minutes to get your mailbox download, which most people don't, then you can serve it out of the US. But if you don't want to do that, and you want to have a user experience that is 3 seconds or less pop time, which is what all the studies have said are about what people are willing to wait today, then you're not going to be serving, the Middle East out of California or Dallas, Texas, or Washington State. The physical bandwidth, you just cannot serve it efficiently in a highly performant manner. Less reliable bandwidth. Various places around the world, their infrastructures at different levels of maturity. We have some countries that we have to serve through their bandwidth or through their networking, and literally they're down. We have outages every other day. And you have to develop your apps so that isn't a catastrophic failure for someone. You have to develop so they're resilient and robust and they can handle frequent outages in the middle of things. No off hours. So, when I first started developing software, and until we actually really started going global at Yahoo, for high-risk launches, we would always do them overnight, right? You'd start at 10 p.m., be done by 6 a.m., because that's 9 a.m. East Coast time. And even if something went wrong, you were covered because there's very few people on that during those hours. Well, when you have something that's actually running globally, there are no off hours. It may be 10 p.m. here, but it's 9 a.m. in India. And that's the beginning of their day, and they're up and running. So it makes it much harder to do things like software upgrades and things, because now all of a sudden, you can't just shut things down, load the new one, and bring it back up. You actually have to load the stuff. You have to keep this running, load the stuff, do your validation, and do a hot swap over. Much more complicated, much trickier, specifically in data-intensive applications. And managing simultaneous rollouts. Again, if you have a product that's going out to multiple countries around the world, to be able to launch it simultaneously into all those markets at the same time, across hundreds of thousands of hosts, across 15 locations, 20 locations, 30 locations, just the technology to allow you to simultaneously push a single package to hundreds of thousands of servers at one time, that in itself is pretty fun and interesting. And pretty challenging to try to figure out how to solve. So, multi-device, we talked a little bit about this. You got browsers, you got smartphones, you got hero devices. That's what they call like the Android and the iPhone, those things. Next, who knows what's next, right? All of this stuff, the bottom three, just happened really in the last 2 years that have taken off, really gotten appreciable critical mass. So A, you have to support them all. B, you have to keep up with emerging technology and make sure that you're at the forefront when things are taking off and become popular. Big deal here. Very similar to the challenges you run into, some of the challenges globally. You really have to be careful that your cost of developing doesn't go through the roof. If you have a separate code base for every single one of these, because they do have different use scenarios, right? People interact with the application differently on a mobile phone than they do on their browser. But if you have a separate code base you have to maintain for every single one of those and all 300 plus mobile devices, you're going to have 400 times the headcount that you have to support, keeping the same features up across all these things, instead of being able to have that headcount focused on new innovation. So it's very important that you want to be able to maximize the common code, while also maximizing the user experience. So the focus on how do I minimize it? It's a very careful balance of minimizing between the amount of code I'm going to have to write, test, bug fix, and deploy, but also making sure that on the phone I have a different experience than I have on the browser, because it's not going to be a very good experience if it's the same as my browser experience, right? And the cost of serving is also much different on multi-device. You want to minimize the number of unique configurations, right? If you have to have separate unique configurations for every device, times every application, times every location, we're not going to have 20,000, we're going to have 200,000 that we're individually having to monitor, maintain, manage, et cetera. Very not something fun we want to do. You also want to minimize the duplication of processing, storage, and transmittal. Right? If we have a mobile app that's a sports app, or let's say a mobile app that is like Flickr, everybody know what Flickr is? It's a photo sharing site. So let's just be silly and use an example that could be, hopefully no rational person would do it. But if we had a mobile Flickr app and a browser Flickr app, at the worst extreme, we could actually have 2 complete versions of every photo that we store. One for the mobile app, one for the browser app. That would literally be tens, if not hundreds of millions of dollars extra just because we're running mobile as well as browser. That's not what we want to do. We want to have one storage that both devices can access. The further up the stack you can take that, the less expensive it will be, and the more money you'll have to spend on other fun things. Okay? Risk tolerance. We mentioned this a little bit. Impacts of an outage. Dollar per outage. There's two big things you risk when you have an outage. One is dollars. The second is your customer satisfaction. So again, if you have a lot of users coming to your site every day and they get used to you and you become ubiquitous with their life, and they count on you being there when they need something, and then you're not there, they get really pissed off. As a matter of fact, the more frequent they come to your site and the more ubiquitous you are in their life, the greater they're going to be really frustrated and potentially not come back if you're down. So the more successful you are, the more important it is that you be up at all times. And your risk tolerance actually, in many cases, has to go much, much lower for the same given app. And so you have to put a lot of new things in. You have to be able to, we call it BCP, business continuity planning, so hot failover, okay? My favorite story of an entire colo going out happened last year. A squirrel got into the power box and blew up the entire transformer at one of our major colos that serves about 35% of our US traffic for most of our major properties. Now, we have BCP, which means we have it set up so that we have a parallel set of infrastructure that's running hot at all times, and we had a very rapid failover of 5 minutes or less. So we lost very little time or outage, and our customer satisfaction was pretty high with how we handled it. But that data center was down for over 36 hours. If we had not had the ability to do a hot failover, we would have been down for 36 hours for about a third of our traffic in our most valuable markets. So but the technology to be able to do a hot failover, that's not an easy thing to do. You have to be at the same state across both places at any point in time. And you get into data replication, real-time data replication, and all these kinds of things that you don't have to deal with if you're not dealing with a very low risk tolerance. If you don't care if the app goes down for a couple hours, no big deal. If you don't care if it goes down and you switch over and you lose maybe the last 6 hours worth of data, that's not that hard either. But if you want to make sure that when you go down, you lose no data of your customers because they really care about it, then it's a lot harder. And that's the kind of challenge you have to deal with. Monitoring, alerting, auto-recovery algorithms, all these things to, again, address the fact that you never want to have a bad experience for your customers. Some of the fun ones, for example, monitoring and alerting, the finance. I think something on the order of 60% of all serious investors in the US use Yahoo Finance for getting stock quotes throughout the day. We literally could impact the NASDAQ or the NYSE if we are serving incorrect stock quotes. So if we're serving the quote from 5 minutes ago and the feed fails and it's cached and it just sits there and it looks like it's still the same dollar amount and it's actually changed dramatically, we could actually impact the stock market in very bad ways. So it's really important that we not do that. So we have to have some very complicated monitoring to make sure that the feeds are coming in. But guess what? The market's only open certain hours of the day, certain days of the week. And by the way, there's holidays built into that. And in every market you go to, there's different holidays. There's different business hours. So the monitoring has to be very sophisticated so that you can actually plug in the individual rules for every new market as you go out there, and it doesn't give you a lot of false positives such that you don't actually see the problems when they come up. Cost challenges, we talked about this. At certain limits, the infrastructure costs more than the equipment. The power, cooling, bandwidth, footprint. It's very easy to spin up something on EC2 if you're just prototyping something. If you're going to launch something that's going to go out to millions, hundreds of millions of customers, not so much. Generic lowest cost denominator versus highly optimized. This is another issue. It's kind of what I was speaking about. If I'm just running something at 30 and it's taxing my CPU at 30%, I don't really care if it's 30, it's 35%. That extra 5% efficiency of my application doesn't matter. But if I'm running this application on hundreds of thousands of servers, 5% efficiency could be tens of millions of dollars a year. So it starts to matter how efficient your application is. It starts to matter how much bandwidth it's sucking up, how many round trips it's having to take for a single action. Those things start to matter when you get to scale, and efficiency starts to become a really, really big deal. So there's two really important things to know when you're going to launch a product. When Yahoo launches a product, we don't, it never launches down here, because by virtue of being Yahoo, even if we don't hype it at all, we're going to get 8, 10 million users that are going to come to the site within the first day. We know that. We've proven it to ourselves over and over and over again. Now, if we really want to hype it up and we put pointers to it from the front page, we can actually drive a lot more traffic. So we can actually, when we launch a new product, we don't start down here. Where we start on the technology curve is usually way over here. And there's several chasms that our applications already have to be crossed so that they don't fall down the minute that the application launches. Okay? The other thing is the rate of growth that we're going to be at is relatively high. And it's interesting because this analogy probably falls down a little bit, because I think the curve actually becomes more exponential as you get successive growth, because the whole viral effect kicks in. Getting to your first million users is harder than getting from 1 million to 2 million. As a matter of fact, I'd probably say that getting to your first 1 million is about the same as it takes to going from 1 million to 10 million. Right? Because once you get that first million, if they really like what you have, they talk to their friends. And if everybody, if they each talk to 2 of their friends, now you're at 3 million not doing anything. And it's a very viral type of thing. And that's where you see companies that will go like this and then crash hard. It's because their technology is down here, and their pace of actual usage has gone way up, and they don't have the right infrastructure in place and the architecture in place to support the challenges that they're going to deal with at the scale that they're at. So the first one is a problem we run into a lot, and it's pretty interesting, and we have people who spend every minute of every day thinking about this. Fighting spam. So again, we're one of the biggest email providers. We also have a product called Yahoo Groups, which has got, I don't know, tens, if not hundreds of millions of users using it every day. And so I'm going to just quickly give an overview of Hadoop first, because I wasn't sure. Does anybody familiar with Hadoop? Anybody know what Hadoop is? At least one person. Okay. It's an open source platform, and it's basically a platform. Yahoo developed it because there wasn't anything that existed out there, but we wanted to get it out there and get it so that everybody uses it. So we actually donated it into the open source arena. And it basically allows you to very quickly create and run applications that can process massive amounts of data. It parallelizes the data process in order to do that. It uses something called MapReduce, which is built on a technology called HDFS, which is the Hadoop Distributed File Service. And what it really does is it takes an application and it breaks it up into small chunks of work. And then it automatically will spawn off multiple numbers of those onto the existing nodes across the cluster. So it's basically breaking things up so they can be done in parallel. It's putting them across multiple places automatically so you don't have to manage it for reliability. And it allows you to do the processing right where the data is located. So it gives you much more efficiency. Okay? So it's, when you're talking processing petabytes and greater of data, something like Hadoop is almost imperative. And that's why we originally designed it, because we had so much data we had to process. The existing technologies out there just didn't meet the needs. So it's useful because it's scalable. It can reliably store and process petabytes of data in a reasonable period of time. It's economical because I don't know how many of you saw Stephen Harrod's talk a couple weeks ago. I watched it on the podcast. This is a cloud technology. This is an example of a cloud where it can basically spawn things off to wherever there is available compute power. So it lets you do that load balancing real time so you don't have wasted resources. Efficient and fast, again, because you can do the processing of the data right where the data's at. It's very, very fast. And it's reliable, again, because it's doing a parallel, redundant pieces of the data of these small pieces. If you lose one, it's got the others there. So it's very reliable. So that's the Hadoop technology. The problem we found, one of the challenges we came in, we had this, I think it was about a year ago. Yeah, it was a year ago, August. We have all sorts of monitoring, as I said, and one day came in and the monitoring was telling us we were getting over 20 million emails a day being generated from Taiwan, people using Yahoo groups in Taiwan. Now this is very interesting because there's only about 18 million internet users in Taiwan. So clearly something's going on there. And this is a case where spammers will go in and create a group and create a bunch of fake people in that group and then use that to go spam. Okay? So that's why you end up with 20 million different sources coming out, even though there's only 18 million users. So the challenge was, how do we identify and delete these abusive groups? Because the groups allow you, a Yahoo group, you can put 1,000 people in it, and all of a sudden, it's spamming left and right. So how do you identify and delete these faster than the new groups can be created? Because quite honestly, the groups were being created so fast, because they automate all this, that we couldn't find them and delete them at a pace to keep up with that. So the solution was, the first thing we did is we looked at existing solutions, because you always hope someone else already has solved the problem for you, and all you have to do is put it in place. And unfortunately, there wasn't something at this scale that existed. So we looked at things like Spam Cop, a lot of the other commercial things out there, open source things, some internally developed things, and they all, for one reason or another, basically fell into one of three categories. They didn't have the ability to be extensible real time. One of the things with spammers is that you catch them and figure out what they're doing this minute, and you shut that down, and they're very creative, and they find another way. And then you shut that down, and they find another way. So you have to have the ability to very rapidly write up new rules and get them inserted and get those added to the process. The lack of ability to handle the volume. This was most of them. Most of them just could not handle the sheer volume of tens or hundreds of millions of emails a day or of Yahoo groups that they had to go through and validate against a rule set. And there was one, Spam Cop actually was an example. They actually could handle the volume, but the effort required to handle the volume was exorbitant. There's no way it made sense to do that. So what we decided was we looked at using Hadoop, and we said, we can use this to parallelize processing of large data sets. And it has a whole bunch of readily available services that make it very quick and easy to create a framework that we can then create very simple rules and just keep adding them. So we developed something, again, the rules are around how do I identify what a group that is a spammer looks like. So a lot of times what a spam group, I can't give you a lot of them because then if any of you are spammers in the house, you would go out and know the secrets. But I can give you one obvious one, which is if someone creates a group and the group contains a whole list of brand new users with Yahoo user IDs, all created in the same day around the same time, that's a pretty strong indicator that that's probably a spam group. So there's those kinds of, first there's figuring out what the rules are, and that's kind of fun. That's really going in and do a lot of data analysis. Then, once you figure out those rules, you have to create the code to automatically go identify those real time and delete them when you find them. Okay? So with Hadoop, we were able to develop the framework literally in a couple weeks, and we reduced the processing time. We first developed the first set of rules without using Hadoop. And as we started to run this, we figured out it was going to take us over 2 weeks to run through one entire set of groups. And as I said, new ones were being created every day, so we could not keep ahead of things at that pace. The processing time went down to less than 2 hours. So now we have an extensible framework that lets us add new rules and can process through the entire Yahoo groups very, very quickly. And this is just a graph. It's a little hard to see. But this was before September, before we started running into the problem. You can see here where we started to get hit pretty hard with some spammers. You can see here where we got the slow one in and started to beat them down a little bit, but we were still getting on the order of 28 million spam emails a day getting sent. And once we got this in place, we took a big dip here. We got a whole bunch of rules in place. It processed through very quickly. And then as they pop up with new ones, we've basically, since a year ago, November, been able to keep that spam at less than 3 million a day. Now, as I said, they're always coming in and trying something new, but our ability to react when a new one comes in at this point is very quick. It can take us minutes to write a rule, get it injected, and get the validation done in less than 2 hours. Okay? So this is an example of a problem at scale that you don't have when you're just creating a new app that's going to go out to a couple thousand users. But when you are the target of spammers, because you are so big and broad, these are the kinds of things you now have to go deal with. And actually, they're kind of some of the funnest and most challenging issues. I'm going to speed it up. We've got about 5 minutes. So the second one is the highly performant global apps. Cost effectively. It's a lot of words. What this means is, let me get to it. As I said, when you start going to global, you're always on this balancing act of performance versus cost effectiveness. So the best performance for someone, if the app is going to run fastest for them if it's being served as close to them as possible. But you don't want to have an instance of your apps. You don't want to have colos and servers running in every single country throughout the world. That's prohibitively expensive, and it's challenging to try to manage. So you want to be able to keep the app footprints as small as possible, but you also want the ability to be able to get a highly performant experience. So it's really that balancing act of how do I get stuff as quick as close to them as possible, but not requiring a lot of hardware and bandwidth to sit there to do it. And so if you look at kind of, for us, we've got users in these countries all around the world. The solution we came up with was something we call the pods, which allow us to basically, and I'll go into it in a minute, but we have a couple big data centers, and more than a couple. We ultimately will have about 13. I think we have 31 today. We're trying to reduce it down to some bigger ones. But we'll have one big data center, and then we have these smaller outreaches that are just a couple of machines. And we have a caching and proxy technology layer that we put in place that allows us to not have to go stick a big fat footprint in every one of these countries, but does allow us to have a highly performant experience. And the way we did this is it's something we developed called YCPI. Now when we actually started YCPI, marketing people won't like this when I say this, but as most things, it was initially generated by some engineers, and so it was named by the engineers initially, so it was the crazy proxy idea, because nobody thought it would work. Now, over time, because marketing tried to change the name to something else when it started to become very popular, and they couldn't, it didn't pick up. Nobody liked the new names. So they changed it. Okay, it's not, you can still call it YCPI, but it's not crazy proxy idea. It's core proxy something. I don't even know. I still think of it as crazy proxy idea. But it's the Yahoo core proxy, maybe infrastructure, something. But what it is really a shared service that allows us to implement some advanced HTTP routing logic. And it enables more reliable services, better and faster, and easy ability to extend and modify. This is really where it counts. YCPI improves this. This top bar up here is the time it takes just to download a page. So if you look at this whole time period here of 1.54 milliseconds in this case, this whole time is the page the complete time. This is just the page download time. So if we can get that significantly reduced, then we significantly improve the performance. Now, by the way, this is what gets worse the further distance you get from where the servers are sitting. So this gets very, very big if you're serving something from Dallas, Texas into Saudi Arabia. So the way we do this is, so example, the download today, the TCP download wastes about 300 milliseconds waiting just for round trips due to the TCP handshake. So I don't know if you guys are all familiar, but basically without YCPI, the first page takes about 600 milliseconds to download. This is for a page sitting, for a browser in California being served out of the West Coast. So the further you get, the slower that's going to be. And this is what it actually does. So what it does is the browser initiates the request, it comes back, and there's what we call a three-way handshake that occurs before it actually starts downloading the page itself. Okay? So what YCPI does is basically the proxy here handles the handshaking, and it's handled out of that pod, so it doesn't have to travel the whole distance to where the servers are sitting. And so you eliminate this going from here to the server, back here to the server, to the base server. And you're just doing it from that very close proxy. And so you're actually able to get this handshake just happening here very quickly. And then it only has to go once all the way to the server and deliver it back. And that allows you to cut significant amounts of time in just one standard download. The other thing is, on multiple page views, it also avoids the handshake completely. If a second page request is done within 5 minutes, it actually uses something called Keep Alive, which most properties don't use generally in Apache because the performance overhead is very high. But the way we've worked out the proxy is we don't pay that performance overhead, and therefore we can use Keep Alive, which means the handshake is kept alive after the first request, as long as the second and third request, et cetera, come in within 5 minutes. So you actually skip that whole sequence. So your subsequent pages are even faster. Does that make sense? Okay, so I'm going to skip the last thing. It was actually another way of using YCPI, not for global, but for actually a sports example, which is where you have 4x the traffic, and how do you handle those traffic peaks? There's other interesting ways to do that. I've got like 1 minute for questions. If anybody, I'll give one question if anybody has a question.
Thanks for sharing all this information with us. I just have a quick question. Let's say someone's have an idea of developing something that would actually enhance Yahoo's website in certain cases. Is there a way to approach Yahoo, or how would you do that? And
I'll give you my card. Okay. I have it.
No, if there's someone, you know, if you try to develop a small company that's based off of Yahoo website.
Well, so there's several different things. So one is we have a very active Yahoo Developers Network, which actually provides a lot of external APIs and web services you can use to take advantage of Yahoo data, et cetera, in applications you want to create. But they actually have a whole forum, so you can contact in through there. The other thing is Yahoo does, I think it's about once a year in the US. I don't know, do you know Hack Days, when we do University Hack Days? Okay, so we do something called Hack Day, and you guys, anybody who wants to show up is fine. You come to the Yahoo campus. We have all sorts of food and snacks and beer and wine and soda, et cetera. We find those things tend to attract university students. I don't know. And the thing is basically, the intent is to, in 24 hours, come up with and basically prototype a great idea. And then we do an actual judging, and we give out prizes and things like that. And you get contact. So I actually judge those a lot. And we have a lot, we have a lot of new college grads we've hired through Hack Days, because they've had great ideas, and then we've actually just hired them on. So I definitely look into the Hack Days, but the Developers Network, which you can get to, just do a search, is also a timely one you can do at any point in time.
My name is Adam, and I have a question. Do you think it's possible to reach a level where problems of scale outweigh the benefits of creating the application?
That's a good question. So his point was, if you keep going and it just gets bloated, at some point it costs more to use the app or to run the app than it does to the benefit you'll derive from it. That's true. Now the interesting thing is, the good news, bad news about capital, a capitalistic economy, is that you usually do business cases on when you're adding stuff and what you're going to do on a general basis. So generally you're keeping an eye on that, and there are those limitations that are put in. But I would also say this, I think it actually is more, I think the user experience would limit before the actual cost would limit. So, if you look at the technology, particularly in the mobile space, that has taken off and been most successful in the last couple of years, it's all around simplicity of design. It's not because they do a million things, right? And actually, when you get out in the working world, one of the things you'll find is if you can possibly do so, you use MySQL versus Oracle. Why? Because Oracle's a great database, but it's so much more complex to use, right? And so if you can get away with it, you use MySQL. And actually, we use it a lot on a lot of things. We pushed it way past the limits anybody ever thought you could use MySQL.
Thank you.
Yeah.